Welcome to the Stormsurf video surf forecast for the week starting Sunday, November 13th. Looking at significant wave heights for the North Pacific Ocean, we see a gale developing in the northern Gulf of Alaska with seas up to 30 feet. And also, right south of that, there is swell radiating east from a gale that was off the Kuril Islands previously. Let's get into the details. Going back in time, you can see on Thursday a gale started developing over the northern Kuril Islands, producing 30-foot seas over a very small area, but aimed southeast pretty well at Hawaii. As it developed later on Thursday, seas built to 35 feet, again aimed pretty well at the Hawaiian Islands, and then continued slowly falling southeast, pushing over the dateline into Friday, again with 33-foot seas, and then finally started fading Saturday with seas from 26 feet. Again aimed at Hawaii and also the U.S. West Coast. That system faded out, and a new system started developing in the northern Gulf of Alaska, producing 28-foot seas aimed mainly at the U.S. West Coast. So the Kuril Island swell mainly will target Hawaii, small energy towards the U.S. West Coast, but this system in the Gulf is going to be the main swell producer relative to California by virtue of it just being so much closer. Let's get into the details. As usual, we'll start our tour with jet stream level winds. These winds up about 30,000 feet help to support the formation of gales. When those gales do form, help direct their tracks. We're looking for a dip in the jet, and we certainly see it right here in the Gulf of Alaska, as we have for the past couple of weeks. In fact, seems to be the hallmark of the North Pacific pattern this year. That is, systems tracking off Japan, lifting gently over the dateline, and then falling into a trough in the Gulf. Again, most of the cold water associated with La Nina is right in this area here, and that north of that is typically where you would have high pressure and the ridge in the jet. And then there's far less cold water over in here, and that's where we would expect to see a pattern of troughiness develop. And that is exactly what has been playing out for a month or more now. Anyway, as of right now, pretty decent winds flowing off Japan, almost split a little bit, but then they get consolidated on the dateline, 130 knot winds, feeding that trough. Roll this out in time, and we notice winds build to 160, almost 170 knots on Monday, again feeding the trough. It's that downward push that would create a counterclockwise flow aloft down at the surface. That's the hallmark of low pressure, and of course low pressure generates wind generates seas. Seas, as they radiate away from the fetch area, produce swell, and of course that makes surf when it hits your beach. Anyway, so that trough continues Monday into Tuesday, and then you see here's the apex, the bottom of the trough right here, just about ready to start moving onshore. Tuesday into Wednesday, but then notice winds pick up again. 1, 2, 3, 4, 1, 2, 3, 170 knot winds right here. So the trough and any low pressure will get a little bit of boost on Wednesday as it moves onshore over northern California. Now also notice at that same time, again, look at this. Here's this ridge. Here's the next trough queuing up in the western Gulf on Wednesday night. Not as much wind, not as much potential for gale development, but still a little bit of a trough working its way through the Gulf. And there you go, starting to dig out pretty nice on Thursday night into Friday. And then more energy building into that trough, and there you go. Look at this on Friday night, a rather broad trough set up being fed by 150, almost 160 knot winds. And there you go. Good support for gale development there, and then it starts pinching off, withering, and again moving onshore now over central. Whoops, there we go. We're at 180 hours. Looks like it's poised to move onshore over central California late Sunday night, and then back to the west. Yet more energy developing. A little bit of a split here, but actually this run of the model looks better than the ones prior, the past 2 or 3 runs prior. So the jet stream looks like it's supposed to be holding together pretty well and infused with a decent amount of energy, providing support for gale development in the future. Let's go take a look down at the surface. So here's the most recent run of the model, 18Z run on the 13th. Certainly, we see a broad gale in the northern Gulf of Alaska with 35 to 40 knot winds aimed mainly bypassing Hawaii, mainly targeting, I'll say, Vancouver Island southward down to maybe Point Conception or so. Anyway, that fetch continues into Monday, and there still, even on Monday night, 35, little patch of 40 knot winds, broad area of 30 knot winds. This is certainly good for a 13, 14 second period swell, targeting the U.S. West Coast. And then we see some other activities starting to develop further off to the west, but not particularly organized yet until 18Z Tuesday. There you go. A little tiny patch of 50-knot winds aimed south at Hawaii and fetch developing in the southern quadrant of this gale, 35-knot winds or so. Let's see where it goes. And whoa, there you go. 50-knot winds almost falling southeast towards Hawaii on Tuesday night. Then moderating, 40-knot winds starting to push towards the U.S. West Coast. Of course, not to dismiss, there's a large gale forecast here over the Kuril Islands, but all of it's, for the most part, supposed to be landlocked. No swell production expected. So this system here is the one of main interest. See, 45-knot winds, but moving directly over Kamchatka. And whatever is east of there is pushing to the northeast, pushing up into the Aleutian Islands. Again, no swell expected. Anyway, this system here, the main focus on Thursday, a little area 40-knot winds, again pushing towards the U.S. West Coast, and it just goes on, and then we're into almost Saturday here, 35-knot winds. Again, just circulating off the coast. Again, we saw a nice trough out here supporting all that development. This just continues on into Sunday. And let's see where we go. And then it finally fizzles out some, but still another little fetch of 30-knot winds out here. Lots of potential for swell development. And then here we go again. Yet another small system forecast pushing off Japan into almost Monday, a week out. Again, don't necessarily believe the model's that far into the future, but the model does hold hope, and that's what counts. Now, these systems aren't as strong, aren't as powerful as the swells, as those that have produced swell that have already hit California. In fact, let's mention a great run of surf, as everyone knows, Thursday, Friday, Saturday, Sunday of a week ago, and then another stronger swell hit Northern California on Wednesday, and then swell also for the Hawaiian Islands over the weekend. The Piahi contest went off quite well, good solid swell there. So the North Pacific off to a good, solid start for the fall. So let's go take a look at what effect those winds have on the ocean surface. And as we talked before, here you see this area of seas down here. We're ignoring that for right now. Right here, these are seas still trying to develop into swell from the system that pushed off the Kuril Islands. This swell mainly targeting Hawaii, expected to hit on Monday, but also notice now a new area of seas, just barely 30-foot seas. They're at mainly 26 feet or so in this area, not filling the Gulf, but getting a good footprint there, pushing mainly towards the U.S. West Coast. We roll into Monday, continued 26, 27-foot seas into Monday night. Then Tuesday, we're down to 25, 20, what's this, 20, 22, 24? Yeah, 25-foot seas. Again, and 25-foot seas will get you a good 14, maybe 15-second period swell. Pushing towards the U.S. coast, continuing. Now here comes our next system on Tuesday night, starting to develop on the dateline. 30-foot seas there, while 20-foot seas continue in the Gulf. That fades out, though. And so we have this small system here over the dateline, pushing east. 30-foot seas, 32-foot seas, and then it just continues to migrate eastward with seas in the 20, 24-foot range, building back to 26 feet on Saturday. 22 feet, 20 feet, and then fading out a little bit, pulsing, but the net result, piles of probably pretty raw surf working its way into the U.S. West Coast. There's potential for rain, south winds from Point Conception northward, so probably not clean, large swell, probably raw swell, better for protected breaks. You know your spot, go find those spots and make the most of this. Let's talk longer-term projections. What's going on with La Nina, and specifically what's going on with the Madden-Julian oscillation? The Madden-Julian oscillation is a pattern that goes maybe 3 or 4 weeks on and off across the Pacific, moving from the West Pacific to the East Pacific. When it's in the active phase, that helps basically feed the jet stream, which in turn helps build gales, which in turn helps produce surf. And when the MJO, the active phase, pushes south of California, it has the potential to produce rain. And then when it turns to the inactive state, it tends to not feed the jet stream, not resulting in less storm activity and a drier pattern relative to California. So first off, we always like to see what's going on the surface on the equator over the dateline in what we call the Kelvin wave generation area. That is the area from 135 east, there's New Guinea there, to just a little bit east of the dateline, 170, and 5 degrees north or south of that. Clearly, we see over the entire equatorial Pacific east winds. All this data is from the TAO buoy array. These are hard buoys on the ocean surface with sensors on them. You can't argue with it. It's not modeled data. Differences from normal for this time of year, that's what really counts. And you see, yeah, it's normal to have easterly winds across here. You see no real indications of anything different. But then you get here into the Kelvin wave generation area. Winds are the anomaly pattern is easterly. That's indicative of the inactive phase of the MJO. And we've been thinking that for a while, but now what we're also saying, well, La Nina is in control, and La Nina tends to amplify trades in this area specifically, and so it would not be unusual to see easterly anomalies. This is not an indication, therefore, of the inactive phase of the MJO, and if the active phase were in effect here, normally you'd see westerly winds. We don't see that either. We're saying this is mainly a symptom of La Nina, and we need to look elsewhere for what the MJO is doing. Another look at wind anomalies. So this is the whole planet on one chart. Kelvin wave generation area basically between these two tick marks going south. This is back in time, October 14th. So you just sort of, when you see blues, that's easterly anomalies. Reds would be westerly anomalies. And as you go down here, you basically see, well, there's a little pulse of westerly anomalies in early November, around Halloween, let's say. Then here's another little pulse over the past week. But then the forecast for the next week is generally a neutral pattern to bias slightly easterly. And this sort of pattern, again, suggests that La Nina is in play and does not necessarily give us a very good indicator of what the MJO is doing. But the MJO is still active, and certainly one can attribute the past 2 weeks or so of swell to an active phase of the MJO, and as we go through the presentation here, we'll show you why we're saying that. Another indicator of the MJO, outgoing long wave radiation. That is, you beam radar down through the atmosphere, reflects off the ocean surface. The stronger the return, the greater the propensity for high pressure. Like here you get a higher, here's the scale, higher than normal return. That means high pressure, clear skies. That means the inactive phase of the MJO. More cloud cover, less return from the beam coming off the satellite. That would suggest the active phase of the MJO. And according to this, the statistical model, the active phase of the MJO is, of course, right here, is the Kelvin wave generation area right in here, and that is, in fact, the case. It's supposed to slowly be dying out over the next 2 weeks with the inactive phase of the MJO starting to slowly ease into the West Pacific. The GEFS model is a little bit more robust and aggressive in terms of how the inactive phase of the MJO moves in, and that the active phase fades out here in about 6 to 10 days, and then the inactive phase comes in, but it weakens too and almost goes neutral by the time it reaches the Kelvin wave generation area. That would be a preferred outcome. Phase diagram charts, another way of looking at where the active phase of the MJO is and what it's doing. Looking down on, let's say, the North Pole, that's what this doesn't represent, but that's a good way of looking at it. Along the equator, the MJO moves from the Indian Ocean over the maritime continent, New Guinea, across the dateline into the West Pacific, into and over or south of California, over the Atlantic Ocean, into Africa, and back to the Indian Ocean. Round and around she goes. Where the dot is, the heavy dot, is where the active phase of the MJO is. This suggests it's probably, somewhere pretty close to California about right now. And the forecast is for it to, the further away from the center it is, the stronger it is. So we've been through a pretty good run of the active phase here for, I don't know, it's about 10 days or so, and it's supposed to fade now and crash as it moves into the Indian Ocean. That per the ECMF model. The GEFS model, the ensemble version of the GFS model, suggests basically the same thing, maybe hanging on a little bit stronger, but by that point in time, it's over in the Atlantic, and it does nothing for the North Pacific storm track in the winter. So pretty much the active phase of the MJO has already done everything it's going to do according to this, and that would suggest that the storm track should probably weaken, if not collapse, over the next week or two. And finally, the output from the CFS model, again, wind anomalies up at 850 millibars, which is up about 4,500 feet, which is a good approximation for what's going on down at the surface. This chart, past history, going this way, current date here, the future forecast here. We'll overlay the MJO, solid contours of the active phase of the MJO. Here is where we are right now. Kelvin wave generation area, 135. So it'd be about from here to 170 west, right along in here. We see a weak active phase of the MJO. This model suggests hints of westerly anomalies, but fading out in the next, week or so. Inactive phase of the MJO is supposed to move in, and a little bit of easterly anomalies, a propensity for easterly anomalies at least. But then once you get into the middle of the inactive phase, that's supposed to die, and westerly anomalies supposed to build. Notice it's just a very weak pattern of the active phase, a little bit stronger the inactive phase, and again a weak push of the active phase out in late December into January. The net result, the takeaway from this is that the MJO is very weak, and it has been very weak, and is to continue to be very weak for the coming 3 months, 2 to 3 months, and probably not, it will modulate La Nina. That is, it'll make it stronger when the inactive phase is in effect, and when the active phase is in effect, it'll make La Nina weaker, and you'll get storm production. But really, this is not like a robust MJO pattern at all, so that you won't get explosive growth. You'll just get sort of a nudge of the storm track, pushing it along, either enhancing it or suppressing it for a couple weeks at a time. So we've talked about the MJO a little bit. Let's talk about La Nina. Clearly, La Nina is in play. This is subsurface, ocean surface temperatures, West Pacific here, East Pacific here. Again, the same buoy array, the TAO buoy array, anchor lines on those buoys. The X's identify where there are sensors on the buoy lines, and then you sort of get and then they sort of model it to fill in the gaps. You see warm water in the west, very shallow warm water pool in the east. This is pretty typical of La Nina. If it was really strong La Nina, you see this really even be much shallower than it is now, so this is not a bad situation. Here's anomalies, differences in normal. The picture has actually improved. You see warm water here, but now we're seeing warmer water starting to build on the dateline, and sort of a brick wall developing here, and our cooler than normal water, which is only 1 degree below normal at depth, and maybe one little pocket at 2 degrees, which is nothing compared to a strong La Nina, is becoming more and more isolated. And this warming, we kind of hope that it holds or builds, but we have seen this develop one other time, and then it kind of got erased. There was a push of cool water that made it went across at depth across this line and sort of wiped it out, sort of like a cool Kelvin wave, but it isn't quite that. Now, there's no expectation that we're going to get a warm Kelvin wave working across here, not at all, but just a very weak indicator of La Nina. The higher res model here suggests that cool water is a little bit more entrenched than was suggested in the previous model, pretty much filling the East Pacific. What do we have? 1, 2, 3. 3 contours, 1, 2, 3, 2 to 3 degrees below normal in here, with maybe a couple of pockets cooler. This maybe is a little overstated. The previous model is a little understated, maybe somewhere between the two. This chart, upper ocean heat anomalies, again going back in time, December last year, cool water, all cooler than normal water at depth in the West Pacific. Kelvin wave number 5, Kelvin wave number 6 into February. That is warm water going from west to east, pushing into Ecuador, and this is the hallmark of El Nino. And then the transition to La Nina, and all the cool water rushed back to the east along the equator, reaching the whole way to Ecuador. And then over time, here we are, we see that pattern really hasn't grown any. In fact, it took a kind of a hit here in August, September, trying to build back a little bit in November, but still just not an impressive La Nina signal at all. Another way to look at this, JSON-2 satellite data, you strip out all the seas, strip out all the wind waves, strip out the tides and other anomalies, and you get this profile of the ocean surface that suggests -5 to -10 degrees centimeters below normal in this area here. At the surface, what that means is cooler water at depth, and cooler water contracts a little bit, so makes a little bit of a divot in the ocean surface by, we're talking a couple of inches here at best, suggesting cool water. So again, this data just sort of maps or helps correlate or support what we saw in the previous charts. Let's take a look at the ocean's surface now, surface temperature anomalies. And the marked difference here is along Peru. If you had a really good La Nina going, you'd see piles of cold water building up here. During El Nino, you see piles of warmer water building up here. While these are pretty warm waters here, these are 2 degrees above normal, you see just right along the coast this thin little band of cooler water, but it's completely like captured, sequestered off on its own, and has been shrinking for a week or two now. Warm water getting a foothold. We're not suggesting that El Nino is developing, nowhere close, but certainly not a strong La Nina. Now, the cool water associated with La Nina here is the Galapagos is isolated here west of the Galapagos, and this area right here has built a little over the past couple of weeks. Most of it was out in here. Now the cool water is starting to build the upwelling, if you will, mainly due to enhanced trades right in this area. It's really starting to move into the eastern equatorial Pacific and not having quite as much of an impact off to the west as it was. And all that means is that La Nina is probably working its way into the mature phase, which is pretty normal about this time of year. December, January would be the peak of La Nina. Anyway, trend over the past 7 days. The blues are cooler trends. The reds are warmer trends. You can see the warming here off of Peru between the Galapagos and Ecuador. Then this is the pattern that's been going on since March or so. These alternating pockets of warmer pockets and cooler pockets, upwelling and downwelling. Not particularly remarkable, consistent at best with what's been going on for months now. If anything, weaker than it has been. And then the big overview picture, and you see this. So here was where the main cool of La Nina cooler waters were, right out in here. But you see now it's made some inroads into the Galapagos area, right in here from 120 to about 100 or 90 west. But not really strong, and just piles of warmer water all around it. So it's really having a hard time getting footing in here and really tearing things out and then getting very cool. So that's, again, when we say La Nina's weak, that's a pretty good indicator right there. The other thing to notice, and see all the cooling up here, this is kind of this, we've had lots of storms go through here, but notice the warmness up along the U.S. West Coast. Temperatures in San Francisco 3 days ago were 61.5 degrees. That's utterly unheard of. I mean, that's warmer than I think we had last year during El Nino. Now, we don't expect that to hold. As winter builds, as storms start working across here, the cold fronts from them, what happens is you get the cold fronts, and they're all stalling out around here. You get south winds ahead of that, and so that's downwelling wind direction, and that helps to build warmer temperatures. If we had north winds, that would be upwelling. That would basically wipe all this out, and there is a forecast for some north winds for a couple days this week. We'll see how much of a dent, if any, it puts in this. Now, the interesting thing is if the Pacific Decadal Oscillation, we've talked about this in previous forecasts here. If the Pacific Decadal Oscillation is really moving to the active phase, this is exactly the sort of pattern you'd expect to see. Warmer than normal water here, cooler than normal water here. That's because more storms are going across here. That creates more turbulence, more upwelling, but then you get this kind of the fronts draping out here, south winds ahead of the southeast to southwest winds ahead of the front, and a downwelling pattern and warming temperatures. Again, we don't know whether we're in the active phase of the PDO. It'll be 6 months, a year, maybe more. But as of right now, that sort of seems to be the case. That sort of seems that maybe what is putting a damper on La Nina development. If you had an epic strong El Nino like we did have, and then normally you have an equal and opposite reaction to that, a strong La Nina, but we don't have that. We have a weak La Nina. We think that, so it's two two oscillations interacting with one another. The El Nino-La Nina oscillation interacting with a positive PDO. The positive PDO is basically would dampen La Nina and it would favor El Nino. So we'll see what happens a year or two or three out, whether that plays out, but that seems to be what's happening, at least on the very short time frame. Temperatures in the Nino 1.2 region, this is the area over there between the Galapagos and Peru. As expected, above normal, half a degree above normal right here. And we have this sort of 3-week down cycle, 3-week up cycle. That's been going on for months now. But still, generally, the balance of temperatures are on the positive side. So close to Peru, normal or above normal sea surface temperatures. But then in the Nino 3.4 region, that's from like 120 west out to 170 west. That's the main area for monitoring El Nino. Temperatures are, in fact, below normal. You can draw a line through this, and they're, about a half a degree or so. We've gone through a cold spell. Now things are warming up again. That same sort of 2-3 week modulation cycle, probably modulated by the MJO, if nothing else. And you see right now we're just about at half a degree. So, 0.59, there you go. So we've talked about sea surface temperatures, we've talked about the MJO. What's the effect on the atmosphere? That's what really matters. So this is the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. Negative numbers represent what we would say is the active phase of the MJO. And you can see if you look at this, the daily numbers, they went quite negative here, down to minus 35 around Halloween. They've been creeping up, but not very much so. I mean, we had a little bit of run of negative there, and just hovering slightly above zero, which is good. The 30-day running average, and this is a good way to measure the MJO sort of after the fact, and you see we were up at +6. And as we got down into the end of October, we went down to -5. We've been holding there. Now we're starting to creep back up again. This would suggest that we were in the active phase of the MJO and that it's starting to fade now. The 90-day running average here, this is how you measure, or one way of measuring La Nina or El Nino. Positive numbers are La Nina, negative numbers El Nino. And certainly positive numbers, we're up at 7.68, but this last active phase of the MJO took sort of a little bite out of that. We got down to what? Down to 4.98. Now we're starting to creep up a little bit. But for a La Nina, this is nothing. And I would expect to see this up at like 15 or 18 if we were in a strong La Nina. And in fact, here's the 30-day SOI average charted out. We've shown this every week. Back in 2014, the start of El Nino, the SOI, you can see the pulses of the MJO in here. Big pulse of the active phase of the MJO going negative. Then the inactive phase, another pulse of the active phase. The trend was steadily downward, and then we hit March of this year or so, major pulse of the inactive phase of the MJO. No active phase is another pulse, and we were up at almost +15. But here you go. This is why we were saying the active phase of the MJO was in effect, because it dipped significantly. I mean, that's a good sized dip there, got us down to -5. Now we're starting to creep up again. So we suspect the active phase of the MJO is fading. All the data suggests that. Now we're going to go into the inactive phase again. Hopefully it won't be a strong one. Hopefully it won't push up as high as this one. That would be a good sign. And then one other piece of data, the ESPI index. This is sort of like the Southern Oscillation Index, only it measures differences in precipitation between the area north of Darwin and Tahiti. The current value, negative numbers suggest dryness in this area, which means lower than normal precipitation, which suggests La Nina. It was up to -1.9 something, but in the past week or two, it's backed off considerably to -1.41. That's good news. That suggests that perhaps the peak of our La Nina has already been reached. And the final piece of our data here, the projections for the Nino 3.4 sea surface temperature anomalies per the CFS version 2 model. Here we are. Here is when we were in the peak of El Nino. Temperatures out in this area of the ocean were above almost 3 degrees above normal. They slid down, of course, as we dipped in. Here's the neutral line. Then we went cooler than normal, half a degree below normal in July. And we've been toggling there down in October, maybe at -0.65 or so. The interesting part is here we are here. and the forecast from this point forward says temperatures are only to get warmer. So this suggests that we're already at the peak of our La Nina, and from here on it should be fading. Normally you don't get the peak until you're into the January, February time frame, and that's when easterly anomalies really start raging. We don't want to believe this too much. It seems hard to believe. I mean, it's really good news if that were true, but it seems too early to declare any of that to be true. But anyway, the trend is we should be up to half a degree below normal by sometime in November or so, and then you get into December and then we just do this slow warm and we're dead neutral by March of next year. And then beyond that, we're up to half a degree above normal in July. That's almost borderline El Nino territory. Now, we don't believe that's going to happen for a second. We suspect we'll go into a second dip into next year, but maybe even weaker than this one. Maybe a 2 or minus 0.2 or minus 0.3 degree negative anomaly. And then after that, it's back to the races, normal temperatures, and back to good times. This is the price we pay right now for having a strong El Nino, and if this is the price we're paying, it isn't too bad of a price, because at least in California there's been some significant surf, and there's even been some good rainfall too. We'll see what happens when we get into December, January, February. That's when we're in the core of winter, but for now, pattern looking pretty positive. So to wrap it up, right now, another gale developing in the northern Gulf of Alaska. Swell poised to hit Hawaii tomorrow from a Kuril Island system. Swell for California expected later by the, some in the next couple of days and continuing, but maybe a bit of a windy, wet south wind pattern setting in as well. That's okay. That is good for California and not a bad thing at all. Get us some snow in the mountains as well. MJO-wise, we're probably moving out of the active phase into the inactive phase, so we'll be into a sort of weaker pattern for the next 3 or 4 weeks or so. That's the way it goes. Some weeks on, some weeks off. And, of course, the PDO, well, we'll see. Things are still looking pretty promising right now. If La Nina is, in fact, we're down as far as we're going in La Nina, that would be beyond good news, but we're not going to believe that either. But all this looks pretty positive as of right now. So that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching, and we'll see you then. Bye-bye.